Hello, everyone, and welcome to this demo of OpenFeature. OpenFeature aims to improve the software development lifecycle, no matter the size of the project, by standardizing feature flagging for developers. Just a quick note that I'll be going through a demo that's available in our GitHub project in the Playground repository. If you pull it down yourself, take note there is a guided tour you can run. I won't be using that today for this video, but if you pull it down yourself, it can be helpful. Okay, let's go ahead and learn how the authors of this fictional landing page are using OpenFeature to manage it. OpenFeature defines provider abstractions that allow the use of a single API to evaluate feature flags, no matter where the feature flags are managed, a SaaS vendor, an in-house implementation, or OpenFeature's cloud-native solution, even a file. In this demo, we'll be using this file, which defines our flags. Just to reiterate, this JSON, the schema associated with it, aren't OpenFeature itself. It's just one provider, just one custom way of retrieving flag values. Okay, so let's imagine that our company is in the middle of changing the name of our app, but legal hasn't quite finished the process. We've defined this flag, new welcome message, that will allow us to change the name of our app and the welcome message without redeploying. So let's go ahead and do that. Change this flag value, and you can see the name of our app has changed. Great, let's take a look at what that looks like in code. You can see here we have a very simple flag evaluation. We just get a Boolean flag value specifying the flag name and a default value just in case the provider can't resolve the flag value from our environment for some reason. And then you can see based on that value, which message we're rendering. Okay, simple enough. Let's try a more complicated flag. Let's imagine that our design team is frequently experimenting with new color palettes, and they want to change our landing page's color. Here we have a hex color flag, and you can see that it defines a few variants as well as the default variant. Let's go ahead and change that to red. We've changed the color of our app on the fly. Great. Let's look at that in code. Here you see a little bit more complicated flag evaluation. It's a string. We're specifying the flag key, the default value, and we also have this hook construct. Hooks are a mechanism by which we can add arbitrary behavior to flag evaluation. In this hook, we're validating the returned value against a regex that represents a valid CSS color. If the color is valid, we return it, else we return the default. And let's see what that looks like in action. You can see one of these variants doesn't quite look like the others, the yellow variant. So let's go ahead and change this to yellow and see what happens. Indeed, we've seen the default value is rendered. So that's our validation hook in action. Let's go ahead and try the Fibonacci calculator. Wow. Yeah, it turns out calculating Fibonacci at n recursively isn't particularly efficient. Luckily, top minds at our company have found a more efficient algorithm for calculating it. It's experimental, so we only want to allow employees to test it. Let's see how OpenFeature can help with that. So I'm going to go ahead and log in as an imaginary employee here. And we'll run it again. Well, much better. So you can see that we have a fib algo flag that's defined here. And in addition to the variance and default variant you saw before, we also have a rule that takes into account contextual information, specifically that my email ends with the particular domain of the company. Let's take a look at what this looks like in code. Here you can see our imaginary third-party Fibonacci calculator implementation. I say third-party because it's helpful to imagine this code was provided by another team in the organization or as an external dependency. That's important because our first-party code did not configure OpenFeature at all when it included this library. You can see the library just includes an OpenFeature string flag evaluation and uses that to select the algorithm to use. Well, you might be asking, how did we inject that contextual information into this flag evaluation? OpenFeature has a global singleton concept that allows us to use implicit propagation techniques available to us in the implementation language to inject contextual data into flag evaluations, even occurring in third-party code. So in this case, we're injecting the user's email into this flag evaluation, which is being passed on to our provider and is used to differentially evaluate the flag. That's it for our demo. Thanks for listening.